You are standing in front of a whiteboard, trying to juggle 5 rooms, 120 students, a handful of guest speakers, and an influx of teacher relief requests. The cognitive load of coordinating all these moving parts at once is overwhelming. The common instinct is to open an AI tool and dump every constraint, bell time, and student count into one massive prompt, demanding an immediate schedule. Alternatively, by adding the command, "Let's think this through step by step," you trigger chain of thought prompting. Think of this exactly like asking a student to show they're working on a complex math problem. You don't want them jumping straight to the final answer. You need to see the underlying logic they use to arrive there. This step-by-step disclosure exposes every branch of the AI's reasoning, allowing you to catch flawed assumptions or hallucinations before they contaminate the final plan. Methodically, let's break down a real-world case study, organizing a STEM incursion. We start with the baseline variables: 120 students, 5 classrooms, and 5 rotating 45-minute sessions. We initiate the prompt by defining these hard boundaries, and we ask the AI to collaborate with us on identifying only the first logical step. The system outputs the mathematical division first, delivering a rotation strategy that moves the students between rooms without any overlap. Now that those student groups are established, what critical variable must be solved next before you can even attempt to build a timetable? You have to solve staffing allocation and identify your exact relief cover needs. Isolating and verifying pure mathematical tasks, like group division, must happen before layering on human constraints. This is how you prevent compounding logical errors from breaking your final plan. With the math verified, we feed specific organizational data, like a teacher availability matrix, directly into the existing chat thread. The AI processes the matrix, assigns supervisors to rotation gaps, and flags where relief cover is required. Next, we integrate temporal constraints. We input our exact bell times, 45-minute blocks, and a 20-minute lunch break, locking the logistics to reality. For the final step, we ask the AI to generate a comprehensive logistics checklist, covering AV equipment, room signage, and duty staff, based entirely on the previous steps. Maintaining thread continuity allows the machine to reference its past decisions, generating highly specific action items for your event, rather than a generic template. The urge to skip steps to speed up the process is strong, but skipping steps forces the AI to guess missing variables, which introduces cascading errors. Breaking thread continuity by moving to a new chat window for subsequent steps has a similar effect. It immediately strips the AI of its required context. This method demands active human oversight. You must verify the logic of each individual output before prompting the next sequential step. Practicing this technique forces you to improve your own project management skills by breaking complex ideas into smaller, actionable chunks. Successful AI coordination requires a deliberate sequence of logical constraints, where the accuracy of the final schedule is built one verified link at a time.